Zoheb Sait. I work for a company called Ocrolus. We are based in New York. We are a startup. And I just want to talk about our crowdsourced document verification system that we built using Flowable. It's been in production for about a year now, and I'll just walk you guys through the product, how we solved it, and some of the lessons we learned. Before I get started, my background, I'm the VP of Engineering. I've been at Ocrolus for about 2 years. Before that, I worked for various startups, big banks. I have about 15 years of experience with software development and architecture. Also with me here is Giriraj. He's one of the core developers that helped build out this platform. So I want to start off by telling you guys a little bit about our product. Has anybody ever applied for a loan and had to provide bank statements? So what happens is when you apply for a loan, you get these bank statements and it goes to some underwriter to review it manually, right? They usually look at the statement, they see if you have enough income, what outstanding rates you have, and then they make a decision on whether you qualify for the loan or not. And it's very often a very manual process. So they look at it line by line. They might miss things. They might end up giving you a loan when they shouldn't have. There's a lot of fraud. People try to fudge statements. There's a lot of things that can go wrong when it's done manually. So our solution is basically a human machine learning hybrid that automates this process. So what that means is we have an API. Our customers can provide us those bank statements using the API, and then we basically use a combination of OCR, machine learning, and crowd to extract the information in that bank statement and give it back to them again via the API with 99% accuracy. So that helps them make these decisions really fast. It gives them a lot of analytics on what was the revenue for this business, things that they need to feed into their underwriting model. And it helps them make the decision really fast. Nowadays, if you go online, for the companies that have this process automated, you could apply for a loan and you could actually get funded the next day. It's not like how it was before. You'd apply for a loan, you'd go to the bank, wait for a few weeks, months to get the loan. It's a very streamlined process, and we are one of the enablers for that streamlined process. So the inspiration for our product really comes from Google's reCAPTCHA. If you guys are familiar with this kind of box you used to get in Google, I don't think they do that anymore. But to prove that you are not a robot, you were shown a little box with some wiggly text, and you were supposed to type that in. What was really happening was Google was using that to digitize the information for their magazines and books that they couldn't pick up with OCR. Right? So they would have a bunch of people enter that information, and they would see if enough people typed it in the same way, then that's how they would transcribe that. So our product kind of uses that as an inspiration. The idea is that you could take these bank statements, you could take the transactions that are in those statements, and you could split them into these kind of CAPTCHA tasks, right? You could show a user like a date, a transaction amount, a description. You could have various people in the crowd work on these components, and then you could put them back together, and you could basically get those results back quite accurately. Because if you strictly just use OCR, even today, the OCR technology just isn't that great. Especially, you have people giving you statements with coffee stains, that have been faxed in, skewed. OCR just doesn't work as well as if you actually use humans along with OCR. So that's really the kind of inspiration of the product, and that's kind of the underlying idea that we built upon for this platform. So. Like I said, it's been in production for a year, but before that, before we started working on this, when I was hired, this was a technical challenge that was presented to me. We had an existing verification system, it was very kind of brittle in the sense that it was hard-coded, a bunch of ifs and conditions, there's no state model. It's very hard to make changes to that system. And then we had to basically, we were growing really fast. There was a great demand for our product, and we were scaling up. So we had to really go back to the drawing board and say, how would we architect this so that we can scale to the increasing volume? I told you guys about the bank statement product, but we also do other documents for lending. So if you apply for a loan, you usually give them pay stubs, tax forms, ID docs, anything that you use for the lending space. We basically provide a solution for that. The other kind of very important feature that we really needed was we needed to support different SLAs for different clients. What that means is if you are an online lender, you can pay us a premium for us to process your documents really fast and get it back. as opposed to, let's say you were like, we have like divorce attorneys as clients. Like they still look at bank statements, but they can wait a week to get the results back, so they pay a lower fee. So it was very important for us to have that feature so that we could prioritize these tasks and get these back quicker to the client. Obviously, the flow was supposed to be at its early stage at that point, so we knew we'd be adding different types of user tasks. And we also needed the ability to kind of grant access to tasks based on the user's qualifications. So what that means is basically we have like a testing process where, like, if you want to work for our platform, you undergo like a little quiz or test, and if you pass that successfully, then you get the qualification, and then you're basically allowed to work on that task. So the architecture we ended up going with was using Flowable as an embedded engine with Spring Boot. So when we built this out, this was last year, I think we were on 6.2 version. We ended up building a custom UI for the task completion management and admin, because how our flow is very, I guess our UI is very complex in the sense that it's very catered to the task. So it's not something we could use the existing Flowable front-end applications to do. So we built up a very custom UI that's used for this task completion. There is also a component mobile application that people can use. The mobile thing only lets you basically do these CAPTCHA kind of tasks. Like, you're shown basically a text and you're supposed to enter the value. Right now we have this rolled out like in the Asian market. So basically, if you're in India, you can go and sign up for this, take this quiz, and you can make money working on these tasks. We use pusher WebSockets for notifications back to the clients. So what that means is, let's say you start working on a task, and if that task for some reason either gets unassigned or reassigned to somebody else, then we basically push that message to the mobile app or the web application to let the user who's working on the task know that the task is no longer assigned to them. So since we run the engine embedded within our own application, we can really easily scale the number of instances, and that works really great with Flowable, because Flowable just cares about having your instance point to the same database, and you could just cluster, or you could put it on a cluster and scale it up or down. For our volume, we definitely needed the ability to scale it up so we can have multiple instances. We are using right now Elastic Beanstalk. Elastic Beanstalk, if you're not familiar with that, it's a AWS platform as a service kind of offering. You can basically give it a var and say I want to deploy these to like X number of servers, and it takes care of everything. We're using Postgres. It's on RDS. For the identity management bit, we are actually just using the Flowable IDM out of the box, but we did some extensions on it because we needed things like to be able to lock out a user if they try to enter the wrong password a few times and stuff like that. Eventually you might move to a different identity management, but for now we're just kind of using the Flowable IDM out of the box. So this is the architecture diagram. It's just an explanation of what I went through, what I just described. The task admin UI, it's basically like a single page app that talks to a load balancer, and then we have these various Beanstalk instances. The Flowable engine is embedded. They talk to our OCR ML engines, which are basically external services as far as like the Flowable REST API is concerned. And we use Flowable admin and IDM pointing to the same database. The admin is really just used by developers. We don't really make it available to anybody in the operations side. We also have the mobile API, which is a different REST API. It also runs Flowable, but it's using a different version of Flowable. We're actually on the 6.4 release for that, and it runs a different BPM flow. The mobile, as I said, the mobile clients actually work on what we call the micro task, which just means that they only see like in the small components of the transaction, as opposed to the people that work in our main web application, where they can do different kinds of tasks. Like they could basically look at a document and help us redact the PII, various different tasks that are at a higher level. The mobile thing is just really for the small CAPTCHA kind of tasks. Any questions on this? And I'm going a little faster. Yeah.
The arrow that you have between the two flowable sections there, is the main application just creating the microtasks?
So the main application, the mobile API application actually gets the tasks from Flowable and it splits it into like smaller micro tasks. So it could take like one. So if you look at a page like let's say a page has 20 transactions, the mobile API basically takes that one task which has those 20 transactions and it splits it into like 60 different tasks for the mobile clients to work on.
Okay, and how do you move the data back, the results back into?
Basically, it writes back to like what's missing over here is our like the shared database between these two. That's a main like repository of transactional data. Like these personal instances are just really the flowable databases, but because they share the same database, they can write the verified result back.
So your applications use different database than the flowable database.
Yeah, the flowable database is really just the flowable tables, some audit logging that we add on top of it, but our main transactional, main store is in the database. So the BPM flow, obviously, I can't show you guys the actual BPM flow because it's proprietary, but it's pretty complex. You know, it's I think if you like used a 30-inch monitor, it'd probably still not fit on it. So we use a lot of different things, but the idea obviously is that we want to parallelize and split the document to as many small tasks as we can, so that if you have a large crowd of people, they can all work on it in parallel. So you're able to get these results back to your users very fast. Because if you, let's say, if you have like a 100-page document and if you assign it to one guy, like it'll take him forever to like go through those 100 pages. What we want to do is like take the document and split into as many small tasks as we can and have everybody work on it in parallel and bring it back together. So I talked a little bit about the micro-task approach. So the way we do this is, if you gave us a document that was like from like downloaded right off the bank's website, then it's usually like a text-readable PDF. In those cases, we can actually completely automate the process. We don't even need humans because we realize that the text is actually in the PDF. There's no CR required. So throughout a flow, we basically make decisions on whether we can automate it, like using either machine learning models, or just be able to like extract or like get that task done automatically. In which case we skip those user tasks, but if not, then they basically get routed to the humans. So it's a combination of humans and machines, that's it. So some of these tasks, external calls that we call, are usually they usually take some time to complete. So if we don't like do HTTP calls to those services, what we do is we kick off the task and we basically end up in a receive task where we wait for a signal back from system and it's done. For example, if you try to OCR a document, it could take anywhere from like seconds to sometimes minutes, depending on the number of pages and the quality of the document. So we basically, for external calls, we just use SQS, we kick off the task, and then we end up in a receive task, so that system knows when the task is completed. So as far as BPM components, I think if you name it, we use it. We basically rely heavily on multi-instance loops, parallel forks, nested subprocess, user signals. There's a lot of service tasks, user tasks, timers, explicit gateways. I think we're a good example of using all BPM constructs because of how complex the flow is. It sounds like it would be a simple thing to solve to analyze, to verify a bank statement, but over the year we've added so many different conditions and changes to the flow that it's pretty complex at this point. But it works well. So this is basically how our custom UI looks like. It's this is like let's say you were a crowd verifier. If you log into the web application, you're basically given a list of tasks that you have access to. Obviously, I've fudged these task names for demo, but you can basically work on any of these tasks that you have access to, or you can click request, which basically just gives you the first prioritized task. But even if you click request on any specific task, the tasks are always ordered by priority. So you get the task that's the highest priority. So we also built out an admin view, which if you have admin access, it basically gives you a view into all the tasks that are currently in the system. You can see basically some of the metadata on the document, the time the document was uploaded, the time it's due, who's currently working on it, and this is basically the candidate groups that have access to that task. The last column is the task. So this is where we have a few kind of operational people that monitor this, see what people are working on. If they want, they could just basically click here and unassign it, reassign it, add more candidate groups. They kind of actively manage the flow of the document. It basically gives them the insight into what's happening in the system at any given time. We also have, as I said, the mobile application. It looks somewhat like this. They basically see the image, they enter the text, they click submit, and it goes back to a server. They can either, if the text is unreadable, they can click unreadable, in which case it goes to a different workflow. But it's a very simple app. You just work on tasks and you get paid out at the end of the cycle for what you did. So a little bit about the task prioritization. Because we needed the task to be ordered by when they're due, we do it in a very kind of it actually works out of the box very simply. So what we do is when we start the process, we basically take the current time and we put it in a priority variable. And then wherever we need the prioritization to apply in the VPN flow, we simply just refer to that priority variable. You could really call this variable whatever you want. It's fine, just define that. And that works really well for prioritization. So I just want to go through some of the other lessons we learned as we implemented this thing. One of the first things we actually encountered when we rolled this out is users started to complain that sometimes the system is slow, and it took us a little bit to figure out what was going on. I wish I had stumbled upon this blog earlier, but this blog article earlier, maybe it wasn't there, but this was a bit of a mystery to actually understand how this works. But basically what happens was I took this from this blog article, but let's say we had something like this. We basically had a user task, and then we had a compute or a service task which has some kind of expensive operation, and then another user task. If that store order task, if that's an expensive task, or let's say it's a task that relies on an external service, and that service is down, when this user completes the task and hits submit, like on a web app, the execution actually happens synchronously. So what that means is that user would basically, his web app would be stuck on the complete thing till the rest of the flow happens. So it was very important for us to go back and make sure we any of those expensive operations that relied on external services were marked as basic. The other kind of important thing that we actually went back and sorted out was since we're using this process engine in an embedded mode, it actually shares resources with the web application. So things like your thread pool, your DB connection pool, these are shared with Flowable and the rest of the web app. So you have to be really careful that Flowable doesn't end up using all the resources. Let's say you had a bunch of jobs and Flowable was executing all those jobs at the same time that are basically exhaust the connection pool, and there would be enough for the web app users. So we actually had to tweak this quite a bit to get this right. These are not the actual values. This is basically I just took this from the samples. But one of the issues we had was I think anybody who's worked on Flowable probably has seen the Flowable optimistic locking exception by now. So usually the solution for that is just to you mark your task as exclusive, your service task as exclusive, and basically what that would do is it will run basically the job one at a time. It will make sure that process instance is kind of exclusive. The jobs are run exclusively. But in our case, we already had the service task as exclusive, but we were still seeing the Flowable optimistic locking exception, and it turns out it was because the job was taking too long to execute, and basically once the lock times out, in this case basically the lock timeout is 5 minutes. If in 5 minutes your task doesn't complete, then another executor picks up the job and tries to execute it, but the other job was still running. So we would end up with these optimistic locking exceptions. So we had to fine tune some of these values to get things right for our use case. The other thing we had to pay attention to was also the retry configuration. By default, Flowable retries everything like 3 times, and in some cases we didn't want that. We just wanted it to retry maybe once, or we wanted like a longer interval between retries in case the system is down. So we had to go back, and wherever we had these external service calls, we had to make sure we configured the retry time cycle correctly. So the other thing with that we built out in the admin screen was an exceptions management. Because we have so many different processes running at any given time, things inevitably go wrong. Like sometimes the service that we depend on is down, or something went down in the system, and it didn't recover. So we built out this exceptions management screen where we list out all the processes that really are have either something in the dead letter job, or basically have are sort of not in the user task. It's not as simple as that, because sometimes it's just running service task, but there's some custom logic to what service task is and how long it's spending. It's spent over there, but basically we built out this exceptions thing that our operations team monitors. They can look at if anything is stuck in exceptions, and we have this little repair button over here that kind of intelligently figures out what it needs to do to repair the process. Usually something as simple as just moving it from the dead letter back to the executor, but it does a lot of different things to try to recover so that they don't really need to come to developers or increase assistance or ask for any assistance for anybody else. This, I think, is self-explanatory. Other than that, they have the option to basically pause, restart, stop, anything that you really can do from Flowable admin. We kind of make it available for our operations to manage the processes. So obviously, I think Yuri mentioned this a little bit earlier. Since we are on 6.2, we tried the process migration. Things weren't that great. We're hoping that 6.4 we could utilize this functionality, because sometimes somebody works on a task and they didn't do it right. We need the ability to roll back to a previous state so that we could redo that task. Currently, we have to restart the process, which usually requires more work. We definitely love that. Also, at this point, we deal with a lot of volume, so over time we have noticed that our database has grown quite a bit. We have a lot of data in the Flowable history tables, so we need to think about how we do structure, kind of almost like maybe archival process that automatically removes some of the data, moves it to a different data store. So overall, the system works great. We had some of the issues that I mentioned. We had a lot of little problems here and there, but overall it's rolled out, and it's been in use for about a year, and it handles several million user tasks per month. It's obviously very concurrent in the sense that at any given moment there's hundreds of people working on these tasks, completing it. So there's a lot of concurrency in the system. As far as the objective or the technical problem that we set out to solve, I think for the most part it works. We're able to add new flows, modify existing flows easily. It's a success story for the most part. I mean, obviously there are little issues here and there that we had to deal with. That's been built out the system. That's it. Thanks to the Flowable team for the amazing framework. It looks great. Do you guys have any questions? Anything you can answer?
How do you test your processes? Because these process models are huge. So
It's testing is something that that's been a little bit difficult, because the processes are constantly changing, so even if you have any kind of test harnesses, like, it's a challenge to keep them up to date. We have some automated testing around this, but we also rely on the QA teams to basically test the flow whenever we make any big changes. But that's one of the things that we actually need to kind of work on, is have more automated tests around when these changes happen.
Who is modifying those processes?
It's developers.
Okay,
Yeah.
always.
Yeah, it's at this point it's complex enough where we actually don't want to.
Okay, and do you find as a developer comfortable to work on a graphical user interface instead of code?
Yeah, I mean, it's not that you're actually coding that much in the modeler. I mean, you just wire things.
It's like visual code.
Yeah, you basically. You still have service tasks behind it where you write the actual code. It's really just wiring it up. It works for the most part. Right. Great. Thank you so much, guys.